Hello, good evening everyone. Welcome you all for another session of regeneration biology, and we will continue with this topic what we covered in the first class, and also we will try to understand what regeneration is different or what way regeneration is different from wound healing, and sometimes during wound healing you end up getting some scar that is formed in the tissue. So that is what today's topic: regeneration, wound healing and scar formation in different regenerative capacity. So this slide I had shown in the previous class, but I feel that there could have been some cropping, so hence I am showing it again for your easy understanding. So the tissue repair is basically the way in which your body responds to an injury and how the cellular proliferation is contributing to the regeneration. So this slide we discussed, so I will not go into the details. So regeneration often results in complete restitution of the lost or damaged tissues. So this is the beauty of regeneration. However, the repair, what we call the milder version of regeneration, it is capable of restoring some original structures but can cause structural derangements. Say for example, if a person's bone is fractured, if the orthopedician did not put the bone, stretch it and put it in the right position, you will end up having a bent bone. So instead of straight, it will heal in that direction. So the structural derangement has to be taken care properly. In healthy tissues, healing in the form of regeneration or repair occurs after any insult that causes tissue destruction and is essential for the survival of the organism. As I told you, if you do not have the regenerative ability, it is very difficult for retaining the functionality of a tissue or even organ. So regeneration refers to the proliferation of cells and tissues to replace lost structures, such as the growth of an amputated limb in amphibians. Amphibians, we all know that if a limb is amputated, it grows back. A tail is broken, new tail comes back. So in mammals, however, this is restricted, quite restricted. The whole organs and complex tissues rarely regenerate after an injury, and the term is usually applied to a process such as liver growth after partial resection or necrosis, but these processes consist of compensatory growth rather than regeneration. Like we saw in the previous class, different category of regeneration. The compensatory growth basically means the function is restored, but the structure is not properly restored. So in this picture, you can see what are the ways in which a injured tissue responds. Soon after injury, there is cellular and vascular response, and soon after the stimulus is removed, in the case of an acute injury, acute means a sudden injury, the parenchymal cell death occurs, that is the intact cell matrix or the matrix of a given tissue is what we refer to as parenchyma, and it happens in many cases of the superficial wounds. Some inflammatory responses are triggered as a acute injury. So in a properly regenerating organism, regeneration is basically the restitution of the normal structure, and some examples include liver regeneration after partial hepatectomy. If you remove completely the liver, new liver cannot form from there. And superficial skin wounds, if you have a tiny knife wound or something on your skin surface, it heals. And the resorption of exudate in the lobular pneumonia. Many cases, pneumonia causes damage to the respiratory epithelia of the lungs and it regenerates back. And when there is parenchymal cell death, it's associated with tissue framework. That means basically the deep wounds, as you can see here, it is responded by a process called healing. There is no proper regeneration, rather it heals, and there is a definitely a scar that is formed, and we call it as scar formation. And here the organization of exudate exists. That means the organ is now very prominent, that there is a damage and it do not look like it is regenerated properly. Some examples include deep excisional wounds and myocardial infarction. When there is a blood supply is stopped to the heart muscles, then we call it as myocardial infarction. Those kind of wounds often leads to a healing response, but it is associated with scar formation. Scar formation means it is a junk tissue that is being filled in that area, but the functionality is not restored, but the structure is retained somewhat. And then comes persistent tissue damage. When there is a persistent tissue damage, that is like people who are eating pan, gudka, those kind of thing, when you put in your mouth, you are constantly damaging your mouth epithelium. So this is not a wound, but rather constant erosion of the tissue, and this also leads to constant inflammation. In such situation, the body responds by a process called fibrosis, and where the tissue scar is very, very prominent. And examples include chronic inflammatory diseases like liver cirrhosis, chronic pancreatitis, pulmonary fibrosis, etc. If you are living in a highly polluted environment, your lung epithelium is constantly under pressure, so they can lead to a fibrotic response, and we often refer to as fibrosis. So if you look into different types of cells, we all know that we are derived from a zygote, and the zygote is basically a initial starting point of a living organism, which give rise to a blastula or blastocyst, and blastocyst contains lots of cells that we call them as pluripotent stem cells. What does it mean? It can give rise to any cell type of your interest, and they differentiate slightly and they become multipotent stem cell. That means they moved away from pluripotency, but they still have the ability to give rise to a bunch of cells. And then comes this multipotent cells. It gives rise to lineage committed cells. Lineage committed means they are moved away from the multipotent status. Now they have committed to give rise to a group of cells. Classic examples include your bone marrow stem cells, which can give rise to only the RBCs and the WBCs, red blood cells and white blood cells. It do not give rise to skin cells or muscle cell or something. It can give rise to only those cells. Say below your skin, you have got skin stem cell that can give rise to only the skin cells. It cannot give rise to any other cells in your body, and they are called lineage committed cells. And these lineage committed cells give rise to differentiated cells, say skin, say bone, or any other adult cells. And endoderm derived, mesoderm derived, and ectoderm derived are the main three groups of these are all the primary germ layers what we are talking about: ectoderm, endoderm, and mesoderm. So they give rise to these cell types, and you can culture these pluripotent stem cells, and they can give rise to any type like pancreatic cells, hematopoietic cell, cardiomyocytes, neurons, hepatocytes. All cells can be derived from this embryonic stem cell. And not only that, adult tissues have got a resident population of stem cells underneath. Like a classic example is your skin. You know your skin has got hair shafts that is coming out. You also have got sweat glands. You also have got sebaceous glands. All these things are located on your skin, and skin has got an epidermis and a dermis. And you can see here there are different dedicated cells are there, and there is also distribution of epidermal stem cells. What do? They can give rise to epidermis whenever there is a skin damage, which happens constantly. You are losing your skin every day, but it is being replaced by this stem cell. And if you look into your intestine, same way your endoderm, intestinal lining, also have got severe wear and tear due to your buccal cavity movement of digested, post-digested materials. And they also have a different types of cells. There is goblet cells for secreting the mucus, and absorptive enterocytes, and enteroendocrine cells that releases hormones, and they also have crypt cells, which are often referred to as the stem cells. And there is also Paneth cells. So these stem cells constantly enter cell cycle to replace the damaged tissue. Same way you have got liver cells, which can give rise to constantly your liver is undergoing damage, and this liver stem cells can give rise to a new liver cell type. That is why even after a liver damage, the liver bounces back. And this is part of your eye. In your eye, the white portion is called conjunctiva. The black portion, when you look into an eye, that is normally layered by cornea. So if there is any damage happen to your cornea, you can go blind. In between this white portion and the dark portion, there is a boundary that is called the limbus. And limbus is the one which can give rise to cornea. So if you can collect this corneal stem cell or this limbal stem cell, you can culture cornea in the petri dish, and people are doing that also for surgical transplantation. So regeneration is something, some tissues are able to replace the damaged components and essentially return to a normal state. This process is called regeneration. So regeneration occurs by proliferation of cells that survived the injury, but is the neighborhood of the cells. And they retain the capacity to proliferate, and in rapidly dividing epithelia of the skin and intestine and in some parenchymal cell glands and mainly the liver. In other organs, tissue stem cells, that what we saw in the previous picture, they may contribute to the restoration of the damaged tissues. However, in mammals, they have very limited capacity to regenerate damaged tissues and organs, especially complex organ. Liver is an exception, but majority of them have got limited capacity to regenerate. Tissues with a high proliferative capacity such as hematopoietic system and the epithelia of the skin and the gastrointestinal tract, they renew themselves continuously because that is the way they live, because constantly there is a damage and they have to replace, and they can regenerate after injury as long as the stem cells of these tissues are not destroyed. So the connective tissue deposition or the scar formation. What is scar formation? When there is an injury, after it is healed, then you can see a mark. You can identify even after several years, oh, there was an injury. That is called scar formation. If the injured tissues are capable of complete restitution, or if the supporting structures of the tissues are severely damaged, repair occurs by laying down of connective or fibrous tissue by a process called scar formation. Although the fibrous scar is not normal, it is enough to provide structural stability so that the injured organ is able to function. If your table is wobbling, what you do, you'll take a cardboard piece or a plywood piece and put it below one of the moving legs, and so that the table is now stable. Same process is scar formation. The term fibrosis is most often used to describe the extensive deposition of collagen that occurs in lungs. Once the scar formation becomes too haywire or too dominant, then we call it as fibrosis. This can occur in lungs, liver, kidney and other organs such as a consequence of chronic inflammation. Inflammation means the reddening, like if a mosquito bite is there on your skin or you had a pimple on your hand, you will see some reddening around that injury spot, and that is called inflammation. But chronic inflammation, something can happen in your body because of various allergens, pollutants and various toxins, etc. It can happen in the myocardium after extensive ischemic necrosis, that is called infarction. If the blood supply to the heart muscles are compromised, then there is a partial damage. Once the damage becomes severe, the contraction of the heart can get affected, and we use the word heart attack or myocardial infarction. In all these conditions, there is involvement of fibrosis. If fibrosis develops in a tissue space occupied by an inflammatory exudate, this is called organization. Organization means not any particular organ that is being formed. It basically created a stable structure on that organ which is derived from the fibrotic tissue or the scar forming tissue, especially organizing pneumonia that affects the lungs. The cell proliferation during a fixation, several cell types proliferate during tissue repair. This include the remnants of injured tissue which attempt to restore the normal structure, and a good example include vascular endothelial cells. Endothelium means the lining of your blood vessels. Blood capillaries, arteries, veins, etc. are there. The lining of those vascular tissue we often refer to as endothelial cells. And keep in mind, for the blood vessels to form, you need to have this endothelium multiplication and a tubular structure formation, etc. This helps in creating new blood vessels that provide nutrients that is needed for the repair process. For a injury response, you need nutrition, oxygen, glucose, etc. Who will supply that? That has to come through your blood system, and the blood will flow only if there is a blood capillaries. And the second category include the fibroblasts. The endothelial cells has to come for the blood vasculature formation, and the fibroblasts are needed to fill the gap. They are the source of fibrous tissue that forms the scar to fill the defects that cannot be corrected by regeneration. So when the scar is formed, if the organ is not able to regenerate, then the scar forms, because the body is filling the gap or the damaged area of the organ with a so-called junk tissues, that is called fibroblast. Fibroblast, when we call it as junk tissue, doesn't mean that it is a useless tissue. However, it do not have a defined organ specific function. So fibroblast deposited in liver, it will not do liver function. If it is deposited in kidney, it will not do kidney function. Deposited in lung, it will not do lung function. However, it will fill the gap. So it is like something like if your tiles in your house is broken, you can replace with exactly the same tile if you have stock. But if you don't have something similar color, you can replace it. If you don't have tile, then what you will do? You will fill with the cement, and this is scar formation. So you can easily identify, oh, tile was here and it is broken. Now they filled with the cement. It will look ugly, but at least the wall will look okay. Wall will not get damaged, or the floor is not looking really affected. So the cell proliferation can be stimulated by physiologic and pathologic condition. Pathology means any kind of infections. Example, the proliferation of endometrial cells under estrogen stimulation during the menstrual cycle, and thyroid stimulating hormone mediated replication of cells of the thyroid that enlarges the gland during the pregnancy, because this happens because you need to have more of the thyroid hormone. And also physiological stimuli, example, may become excessive, creating pathologic conditions such as BPH, benign prostatic hyperplasia, resulting from dihydrotestosterone stimulation and the development of nodular goiters in the thyroid as a consequence of increased serum levels of TSH. So these are all some conditions in which you can end up getting some sudden nodules and fibrosis. The cell proliferation is largely controlled by signals from microenvironment that either stimulate or inhibit proliferation. Just like a car, your car need to have accelerator and brake. What if your car has only either one of them? That car is useless. So you should have stimulation and also inhibition. And excess of stimulators or a deficiency of inhibitors lead to net growth, overgrowth. You don't know when to stop it. And in the case of cancer, uncontrolled cell growth happens. Say you had a wound, and that wound has to heal by cell proliferation. What if proliferation doesn't stop? So it will lead to cancer. So normally it doesn't happen because the inhibitory signals are working fine. The tissues of the body are divided into three groups on the basis of proliferative activity of their cells. They are three categories: continuously dividing one, we call them as labile tissues; quiescent one, stable tissues; and the non-dividing one, permanent tissues. They are broadly categorized into these three. So you can see, many of you have seen this in your intermediate or in school class textbooks. This is called cell cycle. Cell cycle, what does it mean? A given cell can be in one of the phases of the cell cycle. The act of a given cell dividing into two is called cell division. So that is normally happening during the mitosis. So a new cell is born soon after mitosis or binary fission or cell division. And this newly formed cell have got multiple options. One option is to stay in their G1 phase, first phase of cell cycle, G1 phase, that is growth phase 1. Many cells which are permanent cells, they will arrest in this G1 phase, and we often refer to them as permanent cells. That means they never ever get into the G1 phase at all. Soon after multiplication, they become permanent cells. Examples include neurons and cardiac myocytes. That means they never explore the possibility of becoming 2 or 4 or 8. So those which have the potential to enter into cell cycle, they will get into the G1 phase, and they are called quiescent stable cells. that means they have come out of the cell cycle. We often refer to them as G0. That means they are basically G1 only, but they have no plan of getting into cell cycle. However, if the stimulation is proper, they tend to enter into the cell cycle. That is what this dotted arrow shows. Enter into the cell cycle, that is, it will get into G1. Of course, it has to pass through the restriction point and DNA replication, everything checkpoint has to pass. Then there is a synthetic phase or S phase, and the continually dividing or cycling labile cells are in this cycling phase, that is G1, S and G2 phase. They will constantly keep on doing, like your epidermal cells, epidermal, GI tract, epithelium. They will not arrest in G0 or this permanent phase. They will be in their cycling phase. And these cells, once they are past the S phase, they will get into G2 phase and then get into, once it passed this checkpoint, G2M checkpoint, it gets into mitosis. So this will continue for the continuously dividing cell, and some partially excited one will be quiescent cell, say for example hepatocytes, and the permanent cells include neurons and cardiac myocytes. So the labile cells, continuously dividing tissues, of these tissues are continuously being lost and replaced. Why they are dividing? Because they are being lost. And these stem cells, and by the proliferation of mature cells. And the labile cells include hematopoietic cells of the bone marrow. That means you need constant supply of blood, and RBC and WBC is needed, and the bone marrow keep on producing your blood cells. The majority of the surface epithelia have these features, and such as the stratified squamous epithelia of the skin, oral cavity, vagina, the cervix, and the cuboidal epithelia, ducts draining the exocrine organs, salivary glands, pancreas, biliary duct tract, etc. The columnar epithelium of the gastrointestinal tract, uterus and fallopian tubes, many examples are there where the labile tissues are there. These tissues can readily regenerate after injury as long as the pool of stem cells are preserved. In old age, what happens? The stem cells can deplete because of various reasons. Your stem cell population is decreasing, hence the labile cell population also will decrease. In continuously dividing tissues, cells proliferate throughout the life, replacing those that are destroyed. These tissues include surface epithelia, columnar epithelium of the GI tract, GI means gastrointestinal tract, and uterus, the transitional epithelium of the urinary tract, the cells of the bone marrow, and hematopoietic tissues. In most of these tissues, mature cells are derived from adult stem cell. We saw a few slides ahead, the intestine, skin, etc. have got the adult stem cells, which have tremendous capacity to proliferate and whose progeny may differentiate into several kinds of cells. They have, because based on the tissue you are talking about, those stem cells can give rise to a minimal set of cell types. When you come to the stable tissues, cells of these tissues are quiescent, that is G0 arrested stage of the cell cycle, and have only minimal proliferative capacity in their normal situation. These cells are capable of dividing in response to injury or loss of tissue mass. So stable cells constitute the parenchyma of most solid tissues such as liver, kidney and pancreas. Also, the mesenchymal cells such as the fibroblast and smooth muscles, vascular endothelial cells and lymphocytes and leukocytes. These all come under this stable tissues. They also include endothelial cells, fibroblast and smooth muscles cells. The proliferation of these cells is particularly important for the wound healing purpose. With the exception of liver, stable tissues have limited capacity to regenerate after an injury, whereas the liver can replace the damaged tissue and restore the function. When you look into permanent tissues, these cells are present in the tissues that are considered to be terminally differentiated and non-proliferative. That means they cannot even think of proliferating postnatal life. They can divide during prenatal life, not during postnatal life. The majority of the neurons and the cardiac muscle come under this category, and thus the injury to the brain or heart is irreversible and results in a scar because of neurons and cardiomyocytes cannot regenerate. Limited stem cell replication and differentiation occurs in some areas of the adult brain. If neurons of the central nervous system is destroyed, the tissue is generally replaced by the proliferation of the central nervous system supportive cells called glial cells. There is some evidence that the heart muscles cells may proliferate after myocardial necrosis, and this is followed by scar formation, but it is not powerful enough to restore the damaged area. Nonetheless, whatever proliferative capacity may exist in these tissues, it is insufficient to produce a proper regenerative response. Skeletal muscles, classic example, that is your body muscles, they usually classified as permanent tissue, but the satellite cells attached to the endomysial sheath provide some regenerative capacity for the muscle. In permanent tissues, repair is typically dominated by scar formation. Repair most often consists of a combination of regeneration and scar formation. It's not one or the other alone. By the deposition of collagen. What is collagen? Collagen is a extracellular matrix protein, and the relative contribution of regeneration and scarring in tissue repair depends on the ability of the tissue to regenerate and the extent of injury. So the scar formed or the regenerative response, everything depends on what is the extent of damage. For example, a superficial skin wound heals through the regeneration of the surface epithelium because you have got the stem cells. However, scar formation is the predominant healing process that occurs when the extracellular matrix, short form called as ECM, framework is damaged by severe or deep injury. The damaged ECM can attract immune cells which contribute to the repair. This is very important for us to understand. But we also talked about the chronic inflammation. Chronic inflammation is something which happens in your body due to various reasons. Especially in old age, your body is more vulnerable for inflammation. Of course, credit goes to your WBCs, macrophages, and various neutrophils that is contributing to this pro-inflammatory response. That accompanies persistent injury. Chronic inflammation can happen because of persistent injury, and also in the case of diabetic ulcers, also stimulates scar formation because of local production of growth factors and cytokines. Growth factors are the one which helps the cell to replicate, or the proliferation of the cells are happening because of growth factors, and the cytokines are the one which can be pro-inflammatory or anti-inflammatory that promote fibroblast proliferation and collagen synthesis, because without growth factors and cytokines you cannot have either of them. The ECM components are essential for wound healing because they provide the framework for the cell migration. Without extracellular matrix, the newly formed cells cannot move one place to another. They are almost like, it is like a railway track. Without railway track, train cannot go anywhere. So how important is railway track for a train? That important is extracellular matrix or ECM network for the cell to migrate. They maintain the correct cell polarity for the reassembly of multilayer structures, and they also participate in the formation of new blood vessels called angiogenesis. So what we saw so far is how and when a regenerative response occurs in a given tissue based on the availability of stem cells or based on the extent of damage. The cells respond, and which is facilitated by growth factors and cytokines, and which is leading to the production of proper extracellular matrix. If it is too much of deposition of collagen, then you will have a severe scar that will be formed and you cannot have enough number of cells. But if the injury is in a manageable state, what will happen? It will give rise to proper healed wound. And healed wound, here what we mean is something which has got the proper maturation of the tissue, and it will often lead to the polarity of the structures, and it participate in the formation of new blood vessels, and that is referred to as angiogenesis. So I will end this class now and see you in the next class. Thank you.